Hi students, in this session we will be speaking about the block over block friction situations. That is, if we are placing one block over the other block and if you are pulling any one block, then how is the friction affecting and when will the two blocks move together and when will the one block slide over the next block and all. So let's understand that through a problem over here. In this case, we are having a 10 kilogram block which is having a 5 kilogram block over it. 5 kilogram block is placed above the 10 kilogram block and they are in a surface like this. Then in the initial state, let me apply a force on the 10 kilogram block. Then if I am applying a small force, what will happen is the two substance will move together without any skidding. The two substance they will move together, that is the 5 kilogram block will be remaining over the 10 kilogram block. But if I am applying a greater force, if I am pulling it suddenly, what happens is the 10 kilogram block will move, 5 kilogram block will fall from the 10 kilogram block. It will fall from the 10 kilogram block. That is, 5 kilogram block won't be able to move as the 10 kilogram block is moving, so that the 5 kilogram block will fall behind. Then we have to understand what is the maximum force that we can apply over the 10 kilogram block. What is the maximum force that we can apply over the 10 kilogram block so that the system is moving as such. That is, the 10 and 5 kilogram block is moving as such. In order to solve these types of problems, we are asked to find out the force. And we know total force will be total mass into the common acceleration. That is, if they are moving as a single system, they will have a common acceleration. Therefore, this is the equation that will give you the total force. For finding out the total force, you know the total mass, that is 5 plus 10, but we don't know the total acceleration. Therefore, we will have to determine the acceleration. Acceleration has to be determined. And in this case, where are we applying force? We are actually applying force over the 10 kilogram block. Are we applying force over the 5 kilogram block? No, we are not applying force over the 5 kilogram block. We are applying a force over the 10 kilogram block. Then why is 5 kilogram block moving with us? Is it stick together? No, they are not sticked together, but 5 kilogram block is moving with us due to the friction. Therefore, 10 kilogram block is pulled with us. We are pulling the 10 kilogram block. Who's pulling the 5 kilogram block? 5 kilogram block is pulled by friction. Friction between the 10 and 5 kilogram is pulling the 5 kilogram. Okay, therefore, that is the key thing that you have to understand in this. The 5 kilogram block is pulled by the frictional force between 5 and 10 kilogram. Okay, for creating a problem like this, let's say the friction between the ground and the 10 kilogram block, let's say mu1, it is 0. That is, for our sake of simplification, we are taking the ground as a frictionless surface. Okay, therefore this friction is mu1 and the friction between the 10 and 5 kilogram, let it be mu2, and let's say mu2 is 0.2. Let us say mu2 is 0.2. The friction between 10 and 5 kilogram is 0.2. Then we have to analyze the frictional force, coefficient of static friction is 0.2, and here the coefficient of static friction is 0.1. No, coefficient of static friction is 0. Okay, therefore we have to find out the frictional force acting over here. The frictional force acting over here, let me write it as force of friction. We know it is mu into normal reaction, coefficient of static friction into normal reaction. But in this case, the coefficient of static friction is 0. Therefore, the frictional force acting over the surface and 10 kilogram mass is 0. Likewise, let's find out the frictional force between the 5 and 10 kilogram. If we are applying a F Newton force over this 10 kilogram mass, friction is applying the force over this 5 kilogram. Therefore, we have to find out the frictional force. Let me write it as FF between the 10 and 5 kilogram. For that also, we can use the standard formula, that is frictional force is equal to coefficient of static friction into normal reaction. In this situation, the coefficient of static friction is 0.2. Normal reaction can be written as mg, where mg in this situation, it is 5 into g. Therefore, let me write the force of friction in this case is 0.2 into m, it is 5. That is, this situation, the normal reaction will be like this, and it is due to the mg force over here. 5 into, let's take g as 10. Therefore, we are getting frictional force as, it will be 10 Newton. Therefore, you just focus over this 5 kilogram mass. And if I am drawing the free body diagram of that 5 kilogram mass over here, the 5 kilogram mass is having a force, that is frictional force, and that is 10 Newton. Okay, so by this 10 Newton force, the 5 kilogram mass is moving with an acceleration a in this direction. Is there any other force acting over this 5 kilogram mass? No, there is no force acting over this 5 kilogram mass. Therefore, the frictional force is the total force acting over the 5 kilogram mass, total force. Therefore, we could use the formula total force is equal to mass into acceleration. Therefore, total force in this 5 kilogram is 10 Newton. Therefore, 10 is equal to, what is mass? We are analyzing the case of 5 kilogram. Therefore, the mass is 5 into acceleration. And you could obtain the acceleration, that will be 10 by 5, that is 2 meter per second square. Hence, now we have determined our acceleration. We have determined our acceleration, and the acceleration is 2 meter per second square. It was the acceleration of 5 kilogram, but it is the common acceleration also. The common acceleration is also 2 meter per second square. It's because the two systems are moving together. Therefore, 2 meter per second square is the common acceleration. Then, since we know the common acceleration, we could use this formula to find out the total force. That is, the total force over this substance, it should be the total force over the substance. It should be total mass into acceleration. What's the total mass of the system? The total mass of the system is 5 plus 10 into acceleration. It is 2. Therefore, 15 into 2, that is 30 Newton. This is the total force. That means if you are applying a force up to 30 Newton, the two systems will move as such. The two substances will move together. But if you are exceeding the force above 30 Newton, then the 10 kilogram mass will move first, then the 5 kilogram mass will be slipped from the 10 kilogram mass. Okay. But if you are applying a force which is less than 30 Newton, then also the two substances will move as such. If you are applying a 20 Newton force, then also the two substances will be moving as such. Okay. Hope you have understood this particular situation. Okay, so now you have understood the first situation. Let's change the situation slightly. That is, in this new situation, this surface, let's say this is having a coefficient of static friction of 0.1. This surface, it is having a coefficient of static friction of 0.1, and the surface between 5 and 10 kilogram, it is having a coefficient of static friction of 0.2. Okay, for our sake of simplification, if they didn't give you the coefficient of kinetic friction, you could take the coefficient of static friction as the coefficient of kinetic friction itself. It will be slightly different, not that much different. Okay, therefore you could take this as the coefficient of static friction or the coefficient of kinetic friction. Now the situation is similar, that is, we have to apply a force over the 10 kilograms so that the system is moving with a common acceleration A. What is the maximum force that can be applied over the system? Maximum force will be total mass into the common acceleration, for which we have to find out the common acceleration. If we have to find out the total mass, total force, we will have to find out the total acceleration. For finding out the total acceleration, let's proceed in the similar manner that we have proceeded in our previous question. Let's initially find out the frictional force between the 10 kilogram and ground. Let me say that frictional forces, let me call it as F1. F1 is equal to mu1 into N1. N1 is the normal force. Is this F1 0? No. In this case, this F1 is not 0. Therefore, what we have to say is F1 is equal to mu1. What's mu1? It is 0.1 into N1. N1, it will be the total mass. That is, this normal force N1 will be mg, where m should be the total mass. That is, the normal reaction over the surface is due to this combined mass. Therefore, I will have to write 0.1 into, what's the total mass? It is 10 plus 5, that is 15 into g, we can take it as 10. Therefore, the frictional force acting over this substance, it is what, 0.1 into 10, it is 1, that is 15 Newton. Okay, this is the frictional force acting over this substance. Okay, then let us find out the frictional force over this surface. Let me call the frictional force, that is, F force is pulling the system, but the 5 kilogram is pulled by the frictional force. 5 kilogram, it is pulled by the frictional force. Let me call that frictional force as F2. We could write F2 as mu2 into the second normal reaction. Let me call it as mu2 N2. It will be mu2 into N2 will be mg, where this m is the mass of this 5 kilogram itself. Therefore, mu2, let me write it as 0.2 into m. It is what? It is 5 into, let's take g as 10. Therefore, this value we know, that is, it should be 10. 10 Newton. It is the frictional force. Then let me redraw that diagram. That is, we can redraw that 5 kilogram block over here. This is our 5 kilogram block, and this 5 kilogram block is having only one force. That is, the frictional force is the only force that is acting over this 5 kilogram F2, and this F2 force is causing this substance to move in an acceleration A in this direction. As we know, F2 value is 10 Newton. Therefore, this F2 can be considered as the total force acting over this 5 kilogram. Therefore, we could write total force is equal to mass into acceleration. Therefore, total force is 10 Newton. 10 Newton is equal to, what's the mass that we have to consider over here? It is 5 into A. Therefore, in this case also, you are getting A is what? 10 by 5, that is 2 meter per second square. In this case also, the acceleration is 2 meter per second square. Okay. Therefore, what happens is, this acceleration can be replaced as the common acceleration. Therefore, what we have to say is, if you are taking this as a single system, after finding out the common acceleration, since now we know these two substances are sticking together, they are not moving apart, therefore we can replace this 10 and 5 kilogram as a single system, that is 15 kilogram. And let's analyze the situation. It is moving in this direction with an acceleration A, but there is a frictional force acting over this substance, that is, the surface is experiencing a frictional force, and that frictional force is, it is F1, and that is what? 15 Newton. We know the acceleration value is 2. Then there will be a force in this direction, that is F. Okay. Then this force is the applied force. Therefore, what we can say from this, it is applied force is winning, since the substance is moving in this direction with an acceleration. Therefore, the net force MA in this case will be applied force minus frictional force. Net force MA will be applied force minus frictional force. What is M? M is 15. A, we know it is 2. That is equal to applied force that we have to calculate minus F1 is 15. Therefore, we could write, let me write it over here, 30 is equal to applied force minus 15. Therefore, in this case, the applied force will be minus 15 to this side means plus 15, 30 plus 15, it is 45. Therefore, 45 Newton is the maximum applied force over here. The maximum force that we can apply over here is 45 Newton. In this case, if you are exceeding 45 Newton, what happens? The block will skid. That is 5 kilogram block will skid. Okay. Hope that you have understood this problem also. Okay students, now let's have another situation. In this particular situation, we are changing the problem slightly. That is, now we are applying the force over the 5 kilogram mass, and all other situations are same. We have to get the maximum value of force that is causing the system to accelerate. That is, the two substances are not sliding apart, they are moving as a single system. For our situation also, let me have the friction over here as mu1, that is equal to 0. the friction at this particular situation, let me write mu2, that is 0.2. Okay, now we have to determine the maximum force that we can apply. In this case also, you should understand, in order to find out the maximum force, we will have to find out the common acceleration. We will have to find out the common acceleration. In this particular situation, 5 kilogram is the block that we are applying force. But the 10 kilogram will also move with the 5 kilogram in our situation. How is the 10 kilogram moving along with 5 kilogram and who is pulling it? The 10 kilogram in this situation is pulled by the frictional force between 5 and 10. That is the key concept that you have to understand in this. The 10 kilogram block is pulled by the frictional force between the 10 and 5 kilogram. Therefore, who is pulling the 10 kilogram block? It's not us, it is the friction between the 5 and 10 kilogram. In this situation also, we will initially find out the frictional force. We will initially find out the frictional force, for which let me mark. This is the first frictional force. Let's call it as F1. F1 will be mu1 into N1. In this case, mu1 is 0. Therefore, we could directly write F1 as 0. Then let's find out the frictional force over here. If this substance is moving in this direction, the frictional force acting over here, that is, let me write F2. F2 is responsible for pulling the 10 kilogram mass. Okay. Therefore, F2, you could draw it in this direction or in this direction. That's not a problem. Then F2 will be what? Mu2 into N2. Then let's substitute mu2. What is mu2? In this case, mu2 is 0.2. Therefore, 0.2 into N2 is normal reaction will be equal to the gravitational force in the situation, since it's a horizontal surface. Therefore, it should be 5 into G, that is 10. Therefore, you will get in this case also 10 Newton is the frictional force. Now we have understood the frictional force is 10 Newton. Then after doing this, what you have to do is you have to analyze the block where we are not applying a force. In the earlier situation also, that is in our earlier situation also, that is in this situation also, we were analyzing the block where we are not applying force. The earlier situation, 5 kilogram was the block where we are not applying the force. But in our current situation, 10 kilogram block is the block where we are not applying force. Therefore, let us draw the 10 kilogram block over here. We are drawing the 10 kilogram block over here. Then this is our 10 kilogram block. The force acting over the 10 kilogram block is what? It is F2. F2 is the only force acting over the 10 kilogram block. And this system is accelerating with a common acceleration, means what we could say is, if the system is accelerating, then the 10 kilogram is also accelerating in this direction. F2 is the only force acting over the 10 kilogram block and it is moving with an acceleration A. Therefore, we could write F2 is the total force and that total force should be equal to mass into acceleration. Then the total force F2, what is the F2 value? It is 10 Newton. Therefore, 10 Newton is equal to 10 into acceleration. In this case, you are getting an acceleration of 10 by 10, that is 1 meter per second square. Therefore, now in this case, we are getting an acceleration of 1 meter per second square. then that acceleration is the common acceleration. That acceleration is the common acceleration. Now we know the common acceleration and there is no opposing force. Therefore, we can write the total force will be the total mass into acceleration. What's the total mass? Total mass is 10 plus 5, that is 15, into acceleration, that is 1. Therefore, 15 Newton is the total force. The total force is 15 Newton. Therefore, hope you have understood this situation. The earlier situation, let's compare the two situations. In this situation, we were applying a force over the lower block. Then we are finding out the frictional force in the both case. Then the block where we are not applying a force, we are taking that block into consideration and we are finding out the common acceleration. The acceleration of this block will be the common acceleration. Then you could find out the total force. In this particular situation, the force that we are applying was on the 5 kilogram. Then we are taking the block where we are not applying the force into consideration, therefore 10 kilogram. Then by using that block, we are finding out the acceleration of this block, that means the common acceleration. After that, we will be finding out the total force. Hope you have understood the situation. These are the important problems that we may get in the block over block friction situation.